Hello everybody, and welcome to exercise 2 on page 31 of the workbook here. And let's read this problem together, see what they'd like us to do. So they want us to find the area between y equals sine of x and y equals cosine of x on the interval from 0 to pi over 2. And you can see that they've provided a picture of us for that area that we're looking for over to the right here. So our region is in kind of two parts. We're looking for the shaded area. We might start here by just nailing down which curve is where in our picture. Okay, so y equals sine of x is a function that goes through the origin, okay, which means that the sine of x curve must be this one right here. Okay, let's maybe label that. And cosine of x is the one that starts at the point 0, 1, so that would be sitting right here in the picture. Okay, now as in any area problem, we need to kind of choose which method we would like to use here. Do we want to think about this area as top minus bottom or right minus left? Okay, well, notice that our two functions are solved for y in terms of x, and so if you kind of sneak a peek, I'm going to scroll back here for just a minute. That's the situation where we're talking about area between functions of x, so top minus bottom is probably the way that we want to go. Okay, well, if you look at the picture, notice that there's a bit of a difficulty here then. Which curve is on the top and which curve is on the bottom in our case? Well, it kind of depends on which part of the region you're looking at. If you're over here on the left-hand side, the cosine curve is the one that's on the top. But if you look over here on the right-hand side, the cosine curve is the one that's on the bottom. So what do we do in a situation like that? Okay, well, we've kind of got two choices. We could either split this into two separate integrals. Okay, notice that the point right in the middle between 0 and pi over 2 is pi over 4. So we could integrate from 0 to pi over 4 and take cosine of x minus sine of x, top minus bottom, and then add that integral to a second integral that goes from pi over 4 to pi over 2, where the functions are flipped around, and we have sine minus cosine. Okay, that would be a lot of work, though. So I'm wondering if you can think of a shorter way of doing that problem so that we don't have to do two separate integrals. Okay, one way would be to notice that these two areas that we have on the left over here and on the right, by the symmetry of the sine and the cosine function, those two areas are equal to each other. So why not just calculate one of the areas and then double it? Okay, that would be a lot shorter. So that's the approach that I'm going to choose here. So the area that we're looking for is going to be the integral from 0 to pi over 4. That's halfway through our interval. Okay, cosine of x is on the top and sine of x is on the bottom in the left-hand half. That integral is just going to give us the area over here because it's from 0 to pi over 4. So if we double it, multiply it by 2, it's going to give us the total shaded area. Okay, let's see if we can do that integral now. So we need an antiderivative for cosine of x. That's going to be sine of x. Okay, and then minus antiderivative of sine of x, it's going to be negative cosine of x. We're going to get a minus a negative, which gives us a plus after taking that antiderivative. And we're going to evaluate between pi over 4 and 0. Okay, so let's see. If we plug in our upper limit, we are going to get sine of pi over 4 plus cosine of pi over 4. Okay, minus the lower limit, sine of 0 plus cosine of 0. Okay, and at this point, you could either go to your calculator or you might remember what these values are from trig. Okay, if you do go to your calculator, make sure that you're in radians. Okay, that's the assumption when we're doing calculations like this in a calculus course. Sine of pi over 4 ends up being square root of 2 over 4, or square root of 2 over 2, and cosine of pi over 4 is also square root of 2 over 2. Okay, and then sine of 0 is 0 and cosine of 0 is 1. All right, and do some simplifying and we'll be done here. So let's see, root 2 over 2 plus root 2 over 2, that's just going to be 2 root 2 over 2, which is root 2 minus 1. Okay, and then finally, if we multiply that out, we could write our answer as 2 square root of 2 minus 2. Okay, and that turns out to be all of the shaded area, okay, that we were asked for in the problem.